Today is going to be 12-4, and we're going to examine quadratic functions again. Today we're going to be converting a general form equation into standard form. So our first example here, it says find the vertex, axis of symmetry, and the max and min of this given function, then graph the function. So for us to graph this, a strategy to use is to convert this function into, because right now this is in general form, and convert that into standard form. Because once it's in standard form, it's super easy for us to just take a look at the vertex and be like, oh, the vertex this, and start plotting points, creating your table, etc. So one of the strategies that we're going to use is we're going to convert this into that standard form, and we're going to use completing the square to do it. So we start with our equation. Now the problem here is because I do have this f of x, without making it ultra complicated, I can't add and subtract things or divide things to both sides. So I have to manipulate my equation by keeping everything on the same side. So I have this x squared plus 10x plus 23. Now we said that we want to get rid of a, and so one of the ways that we get rid of a is by isolating these x's. We say, hey, these are going to be together, and we ignore this c for now. Because supposedly if I'm supposed to add or subtract this c to both sides, that means I don't need to worry about c. So by grouping these two values together, I'm ignoring c for now. Now if there was an a for me to factor out, I would factor it out, but in this case there isn't. So now I want to complete the square inside this parentheses. And so b over 2 squared, well, my b is 10, so I'm going to get 10 over 2 squared, which is the same as 5 squared, which is 25. Now this is where it gets a little strange, because I know that 5 squared is going to be 25. But I can't just add 25 out of nowhere. I need the 25, but I can't just add it out of nowhere. So what we're going to do is, it's an algebra trick, is we're going to add the 25 because I need it to be able to factor this. But for me to put that 25 there, I also have to subtract 25 because 25 minus 25 is 0. So technically, all I'm doing is just adding 0. I want the 25 so I can combine these together by factoring, but I need to include that minus 25 there as like a byproduct. It's kind of like if you think of a juicer and you juice some fruit, you get left with like the peel and the pulp and all that stuff. That's just the byproduct. I want the juice, but I'm left with all that other stuff that I have to deal with. It's kind of like that. So now if I'm left with this 25, this will factor. And so you want to do off to the side, if you do the Xbox method or whatever it is that you use, just know that it's going to factor into this x plus 5 squared. Remember the shortcut, we could just take this 5, and I know it's going to be x and then plus 5 since that's a positive 5 squared. Now that minus 25 is still there. Now if there was something in front here, you'd have to distribute that. So like if there was a 1, you'd distribute that 1 through. And so this is going to be 1 times this, so it's just x plus 5 squared. 1 times negative 25, so that's negative 25, and then the plus 23. So adding those together, I'm going to get my function being x plus 5 squared minus 5. So now my vertex is just negative 5, negative 2. My axis of symmetry we established is x equals h, so that's going to be x equals negative 5. And then the max and min, we said that it's always going to be k. Well, because my graph is going up, because a is positive, I know it's going to be a minimum. It's going to be the lowest value. Even kind of sketching this, this is the smallest possible value, so this is going to be a minimum, and it's going to be a minimum of negative 2. So now putting all this information on the graph, if I were to graph it and go through and you pick points, and we pick points, and we pick points, we already know how to do all that stuff. I can graph my points, and I can create my graph. So all I did was just create it. So there we go, I answered it. The point of this lesson, though, is this portion here. How do I take this function and convert the general form into standard form? Example number 2, same idea. So I take my function, but I want to isolate the x's, and you isolate them because remember, we're ignoring that c. So now that they're isolated, if there's an a, you have to factor it out. Well, this is 1 over 2. So I have to factor out a half, and if I factor out a half, what ends up happening is this is going to turn into x squared, but this is now going to double. Now the way that you check to make sure you did this right, if I multiply this 1/2 back through, I should get this value. 1/2 times this gives me the negative 4x. So I did it right. So now I do the b over 2 squared again. So I take the negative 8 divided by 2, square it, and I get that 16. And so I take the 16 and add it and subtract it on the inside. Now using the shortcut, this factors, and it'll factor into this x minus 4. That minus 16 is still there, and I still have this plus 8. All I did was change my parentheses into brackets to make it easier to visualize. Now I have to distribute this 1/2 to both of these. So 1/2 times this is just 1/2 times x minus 4 squared. 1/2 times negative 16 is negative 8. And so now this negative 8 and this positive 8, they add together and they disappear into 0. So now I just have this 1/2 times x minus 4 squared. So now finding the vertex, so I don't have a k, it's 0, so it's going to be 4, 0. My axis of symmetry is x equals h, so it's x equals 4. And then the max and min, well, it's facing up again, so I know it's going to be a minimum, and there's no k here, so it's going to be a minimum of 0. So now graphing it, we already know how to do. If I plot my vertex at 4, 0, and then pick smaller values and greater values, and this is just the work finding all the different values for that. And so once you have it, you can go through and you can plot it, and then you get your graph. Let's look at one more. So this one is negative 2x squared plus 10x minus 23 over 2. So once again, I want to isolate these x's here. So isolating them. And so when I do that, I can factor out this negative 2. And so if I factor out the negative 2, I get the x squared. And then that becomes 5x. And so now if I do b over 2 squared, okay, I get this negative 5 divided by 2 squared. I'm going to get 25 over 4. So I have to add and subtract that 25 over 4 on the inside of my parentheses. Now this part factors, always factors, the shortcut x minus 5 over 2. And so that'll turn into the minus 5 over 2 squared. This stayed the same, that stayed the same, that stayed the same. So now I have to distribute this negative 2 to both of these. And so negative 2 times all of this, so I have that there. Negative 2 times this, I get this 50 over 4, but that reduces into 25 over 2, and so now adding those together, that's going to turn into a positive 1. So my vertex is going to be 5/2 and 1, which means my axis of symmetry is now going to be x equals h, so it's x equals 5/2, and then my max and min, because this is negative, it's going down, which means it's going to be a maximum, and so it's going to be a maximum of my k. So it's going to be a max of 1. So now graphing it, picking values, and I just pick values smaller and bigger. And so now going through and graphing it, you get your answer. Okay, so in concluding this, what did we learn today? We learned how to convert a general form quadratic equation into standard form. And we, for number 2, it says, what did we use to convert from general form to standard form? We used completing the square. And then what is the vertex of a standard form quadratic equation? That's going to be hk, and we get that from that standard form, x minus h squared plus k. If you guys have any other questions, this concludes our lesson. Please leave them in the comments.